So today we're going to look at graphing functions from standard form. For your central question, I want you to explain step by step the process of graphing from standard form. So you're going to see that with standard form, there's a little bit more algebra or a little bit mathematical work that has to occur before we're actually able to graph from standard form. So before we get to the vocabulary and our guided practice problems today, I want to take a look at a few problems here. So we have 3 different equations here, all in vertex form. And we have 3 different equations here, all in standard form. So if you take a look at our vertex form, let's go ahead and identify our vertex. So the vertex from vertex form is +3, +4. And I want to take a look at our standard form and see if there's any relationship specifically between the numbers in vertex form and the numbers in standard form. So our first value, the h value of the vertex, or the x value of the vertex, we're going to kind of use those two interchangeably here. Is there a relationship between 3 and any of these numbers here? Well, yeah, we see that there's a 3 in the 13, but that's not really a relationship. But what about the 6? What's the relationship between 3 and 6? Well, we know that 6 is 2 times 3, right? But then this would also be the opposite because our 3 here is positive. Well, let's take a look at the second one and see if that same relationship exists. So for the vertex of this function, it's -4, -6. So again, that h value is -4, and that b value from standard form is also twice its value, but again, the opposite. Okay, so let's take a look here. Our b value is 4, and over here, our vertex is -1, +9. So 4 is not twice -1, but notice that we also have an a value here, so that changes things up a little bit. So what I want to show you here is that there is a relationship between this b value and the h or x value from your vertex. And that relationship is that x, or h, because it's the vertex, is equal to -b, so the opposite of b, divided by 2 times your a value. Well, in standard form, there's that invisible number out in front of your x squared. Make sure you're not using 0. Remember, that invisible number is always a 1. So if we take our numbers from standard form and we plug them in to this formula here, we call this vertex formula, does it give us this same x value? So x equals -6 divided by 2 times a, which is a +1. And so this simplifies to a +6 divided by 2. Well, 6 divided by 2 gives us a +3. Let's see if it works for this one as well. So x equals -8, so just -8, divided by 2 times a. Again, it's a 1. So that gives us -8 divided by 2, which equals a -4. Let's check it with this last one where we actually have that a value other than 1. So x equals -b. Our b value here is a +4, divided by 2 times a, and our a value here is 2. So we have -4 divided by 2 times 2, which is 4, and that simplifies to a -1. And so given an equation in standard form, we are able to use this vertex formula to help us find the vertex so that we have our starting point when graphing in standard form. So let's go ahead and write this down in our vocab. So our first vocabulary term, again, is standard form. Standard form is y equals ax squared plus bx plus c. And our vertex formula, this is new to us today, to find the x value of the vertex, or the h of the vertex, x equals negative b divided by 2 times a. And again, those a and b values come directly from standard form. So we have to make sure that our function is always in standard form before we start plugging stuff in to Vertex Formula. All right, so let's take a look at how this works when we are graphing. So the first step, now make sure you guys reserve the right-hand column for your toolbox. Okay, don't let it be an afterthought. Fold your paper now. 1.5 to 2 inches, right-hand column, call it the toolbox, and make sure you're adding steps as we go. So our first step is still to identify the vertex. Now that's not as easy for us when we're in standard form, like with Vertex Formula where we can just see it. So we have to use our Vertex Formula here to find our vertex. So we want to go ahead and identify A, B, and C. So we're just going to say A equals 1, B equals 4, and C equals -5. So to find the vertex, we use x equals negative b over 2a. So negative, our b value is 4, divided by 2 times 1. And then we go ahead and simplify. So that's a -4 divided by 2. And that simplifies to a -2. So for the vertex, the x or the h value is -2. But we still have to figure out the y value of the vertex, or the k in vertex form, right? Well, notice in our equation here that it says y equals x squared plus 4x minus 5. Well, we want to find the y value when x equals -2. So what we're able to do now is take that -2 and plug that in to our equation here. Okay, so once you find the x value of the vertex, you're going to plug the x value into the original equation for x to find the y value. So y is equal to, make sure you use parentheses, -2 squared plus 4 times -2 minus 5. So -2 squared is -2 times -2, which is a positive 4. 4 times -2 is a -8 minus 5. 4 minus 8 is a -4. Minus 5 gives us a -9. So our vertex here is -2, -9. From there, we take a look at our A value, just like we did in vertex form. We take a look at our A value to determine if our graphing pattern is the same as the parent function, or if we have to multiply it. Well, our A value is 1, so we're going to use the same pattern as our parent function. So 1 over 1, 4 over 2, 9 over 3, 16 over 4, etc. So we're going to start with our vertex at -2, -9. Make sure you draw your axis of symmetry. So our axis of symmetry is x equals -2. Then we can go ahead and apply our graphing pattern. We go up 1, over 1 in both directions. Back to the vertex, up 4, over 2 in both directions. Back to the vertex, up 9, over 3 in both directions. Back to the vertex, up 16 and over 4 in both directions. That's as many points as we can fit on here. Remember, you always put as many points possible. And go ahead and connect your points to make your parabola. Now, the last thing what we want to do is we want to verify that our y-intercept matches our constant. Now, we saw in lesson 2.5 that those two values are the same number. So once we graph this, we want to check the constant from standard form and verify that the y-intercept is at that same value. Because if it's off, then we did something wrong and we need to fix it. So we verify our y-intercept is at 0, -5, and our constant is -5. Therefore, we did this well. Again, make sure you have stuff in your toolbox. Go ahead and rewind and listen again if you missed anything, and make sure that you chock that thing full of information. Let's take a look at one more. So for this one here, we're going to follow the same steps as we followed with GP1A. The first thing that we need to do is find the vertex. So using Vertex Formula, x equals -b/2a. So let's identify A, B, and C. A is now -2, so that changes things up a little bit. B is -12, and C is -8. So to find the vertex, we plug in x equals -b. Well, B is a -12. So make sure you have both of those negatives written out so that you don't miss a sign. Divided by 2 times A. Well, our A value is also negative, so we have 2 times -2. So we simplify this. A -12 becomes a +12. Divided by 2 times a -2, which is a -4. And that simplifies to -3. So the x value of the vertex is at -3. To find the y value, we have to input the x value back into our function to find the output, which is the y value. So y is equal to -2 times x. Well, again, we're plugging in -3 for x. Minus 12 times -3 minus 8. Now make sure you follow the order of operations here. That's extremely important. Remember, we have to use exponents before we can multiply. So -3 squared is -3 times -3, which is a +9. So we have -2 times a +9. Now here we have a -12 times a -3. That's going to become a +36. -2 times 9 gives us a -18, plus 36 minus 8. -18 plus 36 is a +18, minus 8 gives us a +10. So the y value of our vertex is 10. So our vertex is at -3, +10. All right, so from here, let's take a look at our A value. A couple of things. First, our A value is negative, which tells us that our parabola is going to open down. The second thing is that the A value is a 2, so we have to change our graphing pattern. So remember, our parent function is 149, but we have to multiply the numerator by the A value, just the numerical value. We don't have to worry about the negative because, again, that tells us that it opens down, and we've already stated that. So we're going to multiply the graphing pattern by 2. So our graphing pattern will now be 2/1, 8/2, 18/3, and that's all that's going to fit on our graph. So let's start with our vertex at -3, +10. Make sure you draw your axis of symmetry. So our axis of symmetry here is x equals -3. Now we can use our graphing pattern moving downwards because our parabola opens down. We're going to move down 2 and over 1 in both directions. Then we go back to the vertex and we're going to go down 8 over 2 in both directions. Going back to the vertex, we're going to go down 18 and over 3 in both directions. Go ahead and connect your points. And the last thing we want to do is go ahead and check our y-intercept. Here we have a y-intercept at 0, -8. And if we check our constant from standard form, they match up, and we did good. And that is graphing in standard form.